All right, trig students, I am looking at the beginning part of section 1, chapter 1, section 5. We're talking about cumulative distributions. Cumulative means it builds. It's building from a small value to a large value. So cumulative distributions give the total number of values less than or equal to a particular value. One major example that you guys are eventually going to come across, and we'll talk more about here in a little bit, are percentiles. You've dealt with percentiles maybe when we're talking about SAT scores, and I'm in the 65th percentile. That means my score is, I should say, there are 65% of the students scored at or below my particular score. Now, it's highly unlikely that they all scored the same. That would be a possibility, but we all know that's not going to happen. So some people might have tied you, but majority of people were less than you in terms of that. You know, that 65% were at or below your score. Sorry for yawning. I am tired. I apologize. Here's a situation in example 1. They have given me a table of rainfalls, and you can see that these are the individual months that are listed here. So they've listed out here the different, they've done a bar graph. Now at first you might look at it and go, okay, that's ridiculous. Why in the world would they go all the way to 14 inches when clearly the highest month is what, 2.5 inches in February? Well, I think the reason they did that is because in a few moments they're going to do the cumulative one. And what they're really going to do is they're going to take, when they go to the second bar, they're going to actually stack the first one on top of that. And then they're going to take those two and stack them on the third. And they're going to take those three, stack them on the fourth. They take those four and stack them on the fifth. And by doing that, what you end up getting is a cumulative distribution. So that's what happens here. And we noticed in the last graph that there was not a lot of rainfall in these months right in here. That's why these cumulative values kind of flatten out a little bit before they start up again. Just because there's a place in the year where you just don't get a lot of rain. In example 2, see what we have here. At 5 a.m., a sudden snowstorm caused Oak School to cancel classes. With no automated message relay system, news had to spread by word of mouth. A table on the next page shows how many of the 170 families knew about the closing from 5 a.m. until 8 a.m. So we have 6 total number of families during preceding half hour. So 6 knew between 5 and 5:30. And then they have a couple question marks there. I'm not sure why. Total families, number of families who know. Well, obviously, if they went from 6 to 14, they added 8, so that would have to have been an 8. And if they went from 14 to 48, that's what, 34? So that'd be 34. So that's all they're getting at, is they're working their way backwards. If you go 152 to 168, you've gained 16 families. Now, obviously, there's a huge jump there between 6:30 and 7 o'clock when news spread fast. Draw a line graph showing the cumulative number of families, and you can see that once we added in the other information, hopefully they have a nice graph that has everything, or maybe they wanted me to do that. So it would be jumping up to this level. I don't know why they didn't put those points in there. Okay, you can read through the rest of that example. Percentiles, as we talked about, that's an example of a cumulative. Always percentiles start at the bottom. We haven't done a lot with percentiles, but we know like the median is the 50th percentile. The quartile 1 is the 25th percentile. Quartile 3 is the 75th percentile. Keep in mind, though, when data sets are small, these numbers, the Q1, Q3, don't exactly fit the 25% and the 75%. They come close, but in In the activity, a school district administered a 30-point math test to all 10th graders in its 3 high schools. The student scores are in the table at the right. Construct cumulative frequency and cumulative relative frequency graphs. Okay, so here's the frequency, 0, 3, 18. So obviously to make them cumulative, you would be adding them. So 0, 3, 21, and so forth. So it started out and it increased quickly, and then it slows down, and the frequency slows down. Okay, well, so when you start adding those things together, and they give you all the information you would need to create a cumulative distribution. It's going to start out small, and then it's going to increase really quickly, and then because there's not as much at the end, it starts to slow down. And if those instructions don't make sense in there, we can talk about that. And that's all you really need to know. Percentiles, we'll talk more about percentiles because those things are kind of tricky.